Hi everyone. So today in this class we will start new topic, chapter number 12, exponent and powers. Okay. So in previous classes we have learned about powers and exponent. Let us recall those concepts. Okay. In previous year we studied exponent and power. So in this year we will recall all those previous concepts. Exponents are mathematical notation. They are represented as a raised to n. Okay, these exponents are a mathematical notation that are used to express how many times number is multiplied with itself. For example, 2 into 2. Here how many times 2 is multiplied? Here 2 times. So we can represent as 1 2 to the power of 2 means 2 square. This mathematical notation, this mathematical representation of how many times the number is multiplied is called as exponent. Clear? So exponents are nothing but mathematical notation that are used to represent how many times a number is multiplied by itself, not by other number. The number multiply itself only, then that notation, that short form is called as exponent. Okay, the number being multiplied is called as the base. This is called as base. The number which is multiplied by itself is called as base. And the how many times, that is represented by base or index. Clear? Understood? Once again I will explain the concept here. Exponent are a mathematical notation that represent how many times a number is multiplied by itself. Here 2 times the number 2 is multiplied, that's why I represented as it is 2 square, means 2 is multiplied by 2 times here. So this mathematical notation is called as exponent. Okay, so this, the number which is multiplied by itself is called as base. How many times that represent is how many times that is represented by index, index or power. How many times that represent index or power. Consider one more example here. 3 into 3 into 3 into 3. Okay, how many times is multiplied here? 1 2 3 4. 3 is multiplied by 4 times, then 3 raised to 4 is the exponent. That is the mathematical notation, that is the representation of the 3 number is multiplied 4 times. This is called as base and this is called as index or power. Understood? Okay. If number a, consider a number a is multiplied by itself n times. The number a is multiplied itself n times, then how to represent it? That is the representation, mathematical representation, a raised to n. Okay, here what it represent? Then the number a is multiplied by n time. The number is multiplied by n time. It is called as the representation of. Okay, this is called as the exponential form, where a is the base and n is the power. Here a is the base, a is the base and n is the power or index. Got it? Okay, next we will move to the exponent having integer as a base. Exponent having integer as a base. Still now we discussed about the positive integer. What about the negative integer? Okay, listen, minus 4 into minus 4 into minus 4. Okay, so we can easily represent 3 times the negative 4, that is negative integer 4 is multiplied, that is represented by this time. Okay, minus 4 is to minus 4 whole cube. Got it? Then what about the rational number? What about the rational number? That is also same. Consider one rational number 2 by 5. Again it is multiplied itself by second time, again third time. Then what is the exponential form of this rational number? That is 2 by 5 to the power of 3. Here one time, second time, third time. 3 times the 2 by 5 rational number is multiplied by itself, then this mathematical notation of rational number 2 by 5 to the whole cube can be represented. Understood? So it is the representation of a rational number in the form of exponential form. Okay. Okay, totally there are 8 laws are there. One by one I will explain. Law 1, first one. Okay, law 1. What law 1 represent? The exponent law 1. For any non-zero rational number a and integer m and n, for any, thus two exponents having same base are multiplied, their products are added. Okay, for example, consider one base with a power m with the same base with a power different power as n. Then first we should take base as it is, then add their powers. Got it? This is the first law. For example, 2 square into 2 cube, that is 2 plus 3, that is 2 raised to 5. Got it? This is the first law. Clear? For any non-zero rational number a and integer m n, thus two exponents having the same base are multiplied, are added. Got it? Next one, second law. Same, for any non-zero rational number a and integer m and n, thus if two exponents having the same base are divided, their power is subtracted. For example, a with the base as a power m, same a with the base as a and power as n, then keep base as it is and subtract their powers. In previous case, here multiplied, having same base with the different powers, then their powers are added and their bases keep as it is. In this case, a raised to m divided by a raised to n, here keep a as it is here, just subtract their power, a raised to m minus n. I will explain it one example here. 2 raised to 5 divided by 2 cube, then keep 2 as it is here, take their power 5 and 10 and 3, 5 minus 3, that is 2 square. Like this we simplify it, okay, using exponent law. Got it? This is second law. Okay, understood? Next I will move to the third one. These all laws we already understood in previous class in the 7th standard. Now third one. For any non-zero rational number a and integer m and n, thus if an exponent is raised to another power, the powers are multiplied. For example, a is a base with a power m, again this exponential form again is raised with another power n, then that time keep base as it is and multiplied the remaining two powers m and n. Okay, for example, 2 square with another power 3, this 2 square is again raised with another power 3, then keep 2 as it is and then multiplied their powers. Okay, 2 raised to 6. Clear? A to the power of m is raised with one power here, again this exponential power is raised with another power n here, keep a as it is here, then multiply their power m into n. 2 square raised with the power 3 here, keep 2 as it is there and multiply their power, 2 raised to 6. Got it? Okay, next one, fourth formula, that is fourth law. For any non-zero rational number a and integer m, an exponent with a negative power is equal to the reciprocal of the base raised to an equal positive integer. For example, a base is raised with a negative integer as a power, then this is equal to the reciprocal of the base with a positive integer with a reciprocal of the base raised to an equal or positive power. Okay, for example, base a is here with a negative power m is here, that is equal to the reciprocal of the base. But here negative power is there, just make it as a positive power. This is the law 5, sorry, law 4. Understood? So for any non-zero rational number a and integer m, an exponent with a negative power is equal to the reciprocal of the base raised to an equal positive power. Understood? Okay. Next one, fifth formula. For any rational number a and b and an integer m, for example, a with a base as a power m, again b with a b as a another one base number with a power n, then thus two exponent having same power with a different base, then multiplied their base and keep power as it is. Okay, thus two exponent having same power with a different base, then multiplied their base and keep power as it is. Okay, for example, 2 square again 3 square, then multiplied their base, keep power as it is. 2 into 3 6 square, that is equal to 36. Understood? This is the fifth law. Okay, in first law the bases are same, powers are different, but in this case bases are different, powers are same, that's why multiply the base and keep power as it is in this case. Okay, next one, law number 6. For any non-zero rational number a and b of an integer m, with the power as m, when they are divided then divide a and b base, keep power as it is. Okay, for example, 2 square 2 cube 3 cube, then 2 by 3 whole cube. 2 cube divided by 3 cube, that is equal to 2 by 3 whole cube. Clear? Okay, this is the sixth law. Okay, next I will move to the seventh law. For any rational number a, any base raised with the power 0, then the result is always 1. So any base raised with the 0 as a power, then the result is always 1. For example, 2 raised to 0 is also 1, 100 raised to 0 is also 1, 1000 raised to 0 is also 1. So any power raised with the 0 is always 1. This is the seventh law. Okay, last one, eighth. Any base raised with the power 1, then the result itself only. A raised to 1 is equal to a, 2 raised to 1 is equal to 2, 100 raised to 1 equal to 1, 1000 raised to 1 is equal to 1, 1 lakh raised to 1 is 1. So any base raised with the power as 1, then the result is itself only. Clear? Okay, there are totally 7 laws are there. One by one I will write all the write all the 8 rules here, and then after that I will move to the exercise. First law, a raised to m into a raised to n is equal to a raised to m plus n. Please by heart all this formula. A raised to m divided by a raised to n is equal to a raised to m minus n. Third one, a raised to m to the power of n, that is equal to a raised to mn. Fourth one, a raised to minus m that is equal to reciprocal of this positive integer a raised to m. Next, fifth rule, a raised to m into b raised to m is equal to a into b raised to m. Sixth rule, a raised to m divided by b raised to m, that is equal to a by b raised to m. Seventh rule, any base is raised with the 1 0 is always 1. Eighth one, any base is raised to 1 is 8 square. Totally 8 rules are there. All 8 rules are very important in solving any mathematical problems. So these formulas also come in future, means in a 9th standard, 8th standard, and in a degree also. Whenever the maths simplifications you are doing, these all formulas will play very important role. So keep remember all these formula. Okay, next, so homework is keep remember all this formula. So in next video I will explain the exercise 12.1. okay. So homework is write 10 times this formula and send to my personal number. Okay.